Okay, now not very often do you see this, but I suppose sometimes in science you might. Like 5 times 10 to the second, plus maybe 6 times 10 to the third. So maybe you have in a journal article this many of some organism and then so much of this organism. And so you're totaling, which is an adding process here. So when you total, you can't add scientific notation. I mean, if you're going to add, you have to have the same units, remember? So with multiplying, you don't have to have the same units. Adding, you do. So if I'm going to add, I pretty much have to write these out. So this is 6. I'm going to move the decimal 3 jumps to the right. It's positive exponents. It's a bigger number. Otherwise, think of that as 1,000. So 6 times 1,000 really is 6,000. And then this one, it's squared. So again, moving it 2 to the right. Or again, think of that as 100. You get 500. So you get 6,500. Now, if they want the answer in scientific notation, then after you add, then you have to go back and say, okay, I need a decimal between 1 and 9.99999. So I'm going to put the decimal right there, right, between those significant digits. And then again, I need some power of 10 to get the decimal to jump there. So 1, 2, 3, 10 to the third would do that. And again, it's a bigger than 1 type number, so it should be a positive exponent. And again, you can check your answer. If I move this 3 to the right, do I get that answer? Or if I take it times 1,000, would that cause that decimal to move? And the answer is yes, so I'm okay. Same thing with, subtraction. All right, so you might have that much of some organism that you're measuring, and so many of them died or something like that, and you want to figure out how many are left. Well, again, this would be 4 decimals right here at the end, and you're going 1, 2, 3, 4. So 1, 2. So let's see, it started out here 1, 2, 3, 4, and then I'm subtracting again 7 and 2 jumps, decimals at the end of my number there. We don't usually write it if that happens, and we get that. So now when I subtract, I can't take away, so I ungroup, I get a 3. When I do that, I get 10 of that unit. Again, that doesn't help me subtract this, so I ungroup, I get 9 of it, and then 10 of those. So then I can subtract, I get 0, 0, 3, 9, and 3. Again, some of you might just be able to do that mentally. And again, I want this in scientific notation, so I take the significant digits, and I put it right there because I want it between 1 and 9.99999 times 10 to the, and then count jumps, not zeros. 1, 2, 3, 4 jumps to get it to go there. And again, if you want to check your answer, you can multiply that out and take it times this and see if it really does work. Now, most of the time we do more like in the other problems where you're multiplying or dividing scientific notation. So remember, when you add, you have to have a common unit so that you can add. So you have to convert these to base 10 numbers so you can actually manipulate them. And with multiply and divide, you don't have to. I mean, I could take miles divided by hours and get miles per hour. That's fine. So here, just a quick review. Again, I can divide and get 0.5, and I can divide here. Now, again, I'm dividing by a tiny, tiny decimal into a so small decimal. So it should go in there lots of times. So again, if you're a trick person, you're going to take a -5 minus a -12, add the opposite, and that's 7. All right. Otherwise, you can think of like flipping these, like putting this up here as 10 to the 12th and this down here as 10 to the 5th, because negative exponents mean reciprocate, and canceling that way. Either way is fine. The only issue is, again, this is not in scientific notation. See how that is not bigger than 1. So to fix it, I'm going to steal a 10 from this guy. So I'm going to take my 0.5 times 10 and then make that 10 to the 6. I'm going to take one of those 10s and put it over here. That 10 is going to fix that problem because 10 times 0.5 would make that 10 times bigger, which makes it 5. Again, move the decimal 1 jump. And there we go. All right, so this is much more typical. Also, the multiplication kind like that are also very typical, where you multiply and then you have to regroup. And I guess I could show that up here. I have a puppy in my lap as we speak. All right, so then the other kind that's probably more typical is maybe something like 4 times 10 to the 5th times, like 3 times 10 to the -8, something like that. Again, they don't have to be in the same unit to multiply or divide. That's okay. So 3 times 4 is 12. And this would be 10 to the 5th and that. So I could add those. What is that? -3. Again, not in scientific notation. So stick the decimal after the first spot. But again, what's that going to do to this? All right. So basically, if you think of it this way, I'm stealing a 10 from that. So I'm taking a 10 away from it, all right, to make it 10 times smaller. So then if I went in scientific notation, I pulled a 10 out, which put that decimal in. Now I have to combine those guys. So 10 to the -2nd. All right, and those are much more typical because sometimes we multiply and divide really tiny, tiny things or big things in science. So that tends to happen more than the adding or subtracting.